All right, let's dive right into this explainer. Today we're going to uncover the awe-inspiring and frankly is sometimes terrifying interconnected systems of our living planet. And we aren't just going to be talking about abstract concepts here. We're going straight to the hard data, satellite observations, and the cutting-edge scientific research that monitors the relentless pulse of the Earth. From deep ocean currents to completely chaotic skies, our planet is a complex, restless machine. And understanding exactly how it works, well, it's literally never been more critical. To really grasp the stakes we're dealing with, just consider one staggering number: over 27,000. That is the number of mass disasters logged globally by the EMDDT database since the year 1900. When you hear a massive number like that, it instantly pulls you into the immense, unrelenting power of the natural world. We're not talking about minor weather events. These are catastrophic moments where nature completely overwhelms human capacity. Section 1. Fire and fractured Earth, the restless ground beneath our feet. The historical volatility recorded by the United States Geological Survey tells a violently fascinating story about the lithosphere. Take the catastrophic 1964 Great Alaska Earthquake, a massive magnitude 9.2 rupture that quite literally tore the landscape apart. Then you've got the devastating blowout of Mount St. Helens in 1980, which was followed by this eerie, silent dome growth years later, stretching from 2004 to 2008. And bringing us right into the present day, scientists discovered new boiling thermal features at Yellowstone's Frying Pan Spring in 2023. Our planet's crust is a highly active, living entity, constantly shifting and steaming right beneath us. And this isn't just ancient history. Right now, today, USGS scientists are tracking active threats worldwide. We have the Great Sitkin volcano on an orange watch, meaning an eruption could be imminent. We have bubbling lava and seismic activity, putting Kilauea and Shishaldin on yellow advisories. Meanwhile, tectonic plates are actively shifting, recently registering a magnitude 5.5 in Peru and a 5.0 right in Texas. The planet simply never sleeps.
It's a pretty suspenseful reality to think about, isn't it? As we track these scattered warnings and tectonic shifts, we really have to wonder, what unseen geological threat is currently brewing just out of sight, just waiting for that immense pressure to reach its breaking point?
Section 2. Oceans on the edge, the rising, warming tide. So, to understand our changing seas, we have to look closely at the mechanics. On one side, you have natural cyclical variability, like the El Niño weather pattern, which Earth observatory data proves can dramatically alter global climates. But on the flip side, we are seeing absolutely unprecedented warming trends observed by NASA and the IPCC, all driven by the expansion of the greenhouse effect. When these natural cycles crash into rising baseline temperatures, the ocean's chemistry and energy levels are fundamentally and perhaps permanently altered. Down at the ground level, this deep water warming translates into some shocking realities. Recently, Copernicus Sentinel-2 satellite data captured shores in Mirbat, Oman, literally turning pink. Why? Because of a massive accumulation of dead shrimp. It was a mass stranding event directly linked by environmental monitoring to sudden, sharp shifts in ocean temperatures. It's visually stunning, for sure, but it's an ecologically tragic indicator of an ocean entirely out of balance. This grim phenomenon forces us to ask a terrifying question about the future of our most vital bodies of water. If a shift in temperature can literally paint miles of coastline pink with dead marine life, what invisible, catastrophic tipping points in the deep ocean are we blindly speeding toward? Section 3. Extremes in the atmosphere, the chaos above. The heat and energy from warming oceans don't just stay trapped in the water. They feed directly into the atmosphere, violently shifting the mechanics of our entire climate system. And the sheer scale of this threat is staggering. Looking at EMDOT's historical disaster data, atmospheric hazards vastly outnumber geological events. We're talking about over 5,750 mass floods and 4,580 devastating storms, compared to just 1,570 earthquakes. Without a doubt, the chaos in our skies is the most frequent, persistent threat to human settlements. The science behind why this atmospheric chaos is accelerating is remarkably clear. NASA's Earth Science Division states this neutrally and factually. There is unequivocal evidence that Earth is warming at an unprecedented rate. Human activity is the principal cause. The data plainly shows that the burning of fossil fuels traps heat, pumping immense excess energy right into the atmosphere. And it's exactly this excess energy that makes heat waves more intense, storms more violent, and severe weather damage far more frequent. It's a looming threat hovering right above our heads. If our history is already marked by nearly 6,000 mass floods, it begs the question, how much more can our modern infrastructure actually take before these extreme, violent anomalies simply become our everyday weather? Section 4. Fading ice and forests, the vanishing frontiers. From those chaotic skies, let's look back down to the biosphere and cryosphere. This is where the planet's vital defense mechanisms are rapidly being tested, and in many cases, they're fading away. The clues of a changing planet are absolutely everywhere, if you just know how to look. For example, scientists are analyzing the color of Adelie penguin guano, which is actually turning pink, to track how marine diets are shifting and the ocean ecosystems change. Meanwhile, high above in Europe, Copernicus satellites are closely monitoring the ancient, snow-covered terrain of Jotunheimen in Norway, watching in real time as these majestic glaciers rapidly retreat under warming skies. Now, there is a really stark contrast in nature's ability to cope with all this. On one hand, studies show that mangroves at the mouth of Guatemala's Motagua River are displaying incredible resilience, miraculously maintaining high photosynthesis absorption rates despite extreme plastic contamination. But on the other hand, data from Global Forest Watch paints a dire picture of our terrestrial defenses, tracking rapid, weekly alerts of massive tropical tree cover loss. Some ecosystems fight back, while others are swiftly being erased. The domino effect of losing these environmental frontiers sets up a terrifying cliffhanger for the future of Earth's resilience. As the ice melts and the last tropical forests fall, we have to ask what critical planetary defense mechanisms we are losing right before our eyes, and honestly, whether we can even survive without them. Section 5. Tracking the unseen threats. The eyes in the sky. But humanity isn't just sitting by passively. Despite these looming dangers, we're fighting back with cutting-edge science. To understand how we track these threats, though, we first have to understand how we define a catastrophe. To even be classified as a disaster by the MDOT database and trigger widespread humanitarian action, an event must meet at least one of these grim milestones: 10 or more fatalities, 100 or more people affected, a national state of emergency, or a call for international assistance. That is the very real threshold of human suffering we are desperately trying to prevent. Monitoring all of this is a massive undertaking. About 2/3, 66%, of these global disasters are driven by the raw, natural forces we've explored today. That vastly outweighs technological or man-made accidents. The sheer volume of natural hazards requires a global monitoring system of an unprecedented scale. To keep us safe, an incredibly advanced, interconnected web of international science operates 24/7. NASA's Earth Science Division alone runs over 20 satellites in orbit. We have the GISTEMP record tracking global temperatures with extreme precision. The European Union's Copernicus program maps the entire globe at a stunning 10-meter resolution. Global Forest Watch beams down weekly deforestation alerts, and the USGS monitors volcanic thermal features and tectonic shifts in real time. It is, quite frankly, a breathtaking technological achievement. We are tracking the planet's every breath, every tremor, and every storm. But I want to leave you with this final provocative thought as we wrap up this explainer. We have the satellite data, we have the supercomputers, and we have the historical records. But as the oceans warm and the ground shifts, are we truly prepared for what the relentless pulse of the planet will unleash next? We're watching the Earth closer than ever before, but make no mistake, nature always has the final say.